So general math students, in the previous video we completed, well we didn't quite complete, we nearly completed this poultry farmer example V2.6, but we didn't do part G, which was asking about whether or not, or which of the answers we could consider to be reliable predictions. So I'm going to talk to you about how we determine whether a prediction is reliable. So here are some predictions that are graphical. In the previous video we did both graphical and algebraic predictions. So graphical means we use the graph to estimate, whereas algebraic is using an equation by substitution. So this is just to give you a picture of the predictions, but we're going to talk about the different things we look for reliability with this example. Okay, so one thing we need for reliability is for the prediction to be an interpolation. So that means that the prediction is within the bounds of the data that's been collected. All right, so you might want to pause the video at this stage and just do a little summary of these ones and see if you can determine which ones are interpolations and which ones are extrapolations. That means they're outside the bounds of the data. Then I'll talk about it. Okay, so by an interpolation, well, you can see that with this first example, there's some data points here, okay? So if we think about the range of the values for x, well, they go from, that's the lowest in line with that data point there. So from here up to here, right? Now this prediction is clearly outside the bounds of that data. Okay, so it's outside the bounds of that data. Now what about for the y? So it's also outside the bounds of that data for y. So that is an extrapolation. So that means that this prediction here is not an interpolation, it's an extrapolation. Sorry, yeah, it's an extrapolation. Now what about the next one? Well, that's the same. This data would go from here to here and here to here, right? But this is outside the bounds of that data, so that's also an extrapolation. This graph, we have an interpolation because the data has that range for those two, and clearly this is within those ranges. So that is an interpolation. So is this one and this one. Okay, so there's the first point, or the first thing we look for reliability. Okay, now the next thing we look for is a high R squared value. So the R squared, remember that's our coefficient of determination. Okay, now if that has a high value, then we can consider our predictions to be reliable, given that all the other conditions are met. So high R squared value, well, you know, normally the calculator tells us the R squared value, but you can kind of tell from these graphs generally whether we get a high R squared value or not, because the R squared value goes hand in hand with the R value. So if correlation looks high, or strong correlation, then chances are the R squared value is also strong or high. So we see the data points in this first graph follow the line quite well. So I think we do have a high correlation there, and therefore a high R squared value. Same with this one. This one, correlation is not so good. The data points are not lying very close to the line of best fit. So I'd be thinking that the R squared value is probably a bit lower on that one. This one, the data points do lie quite close to the line of best fit. And so they do, and they do as well in this one. Okay, so just the one of the graphs there that has a spread of data points, so probably a lower R squared value. So that's unreliable if the R squared value is not high. Okay, so the final thing we want to ascertain is, have we collected enough data? So plenty of data points. All right, now remember the example of the Challenger disaster where the NASA scientists only considered 2 data points of all the 24 launches. So they used very little data to make their prediction. That meant the prediction was unreliable. So this looks like plenty of data points, and so does this one, about 10 or 12, something like that. This one's got lots of data points as well. Now this one clearly doesn't. There's only 3 data points here. That's a small data set. So the relationship might not truly be revealed if you only collect that many data points. And this graph here also has lots of data points. Okay, so we can see that of all these options, it's only the last one that ticks all the boxes. It has, it's an interpolation to begin with. Now, even though these 2 on the far left tick the other boxes, the fact that they're extrapolations means that they're unreliable. Doesn't matter if we have a high R squared value and lots of data. If we're making extrapolations, that's always unreliable. This graph here had the problem where it didn't have enough data points. It had high correlation and it was an interpolation, but just not enough data points. So in the end, this is the only one that ticks all the boxes. It's an interpolation. There's a good correlation there, which means a high R squared value and lots of data points. And an interpolation as well. Okay, now let's go back to part G here, and you might want to pause the video at this stage and determine which of these 3 predictions, and it might be more than one of them, but which ones are reliable based on interpolation, high R squared value, and number of data points. So I'll talk about that in a moment. Okay, so I'll have a chat about this now. So the prediction in part A is clearly an interpolation. So we'll tick the box for interpolation. I'll just write inter. Okay, now high R squared value, we can see here it's big. It's up near 1.9293, so 92.93%. That's good. The R squared value is high. And plenty of data points. Well, there's not heaps and heaps, but there's several data points, so we'll tick that box as well. So this is reliable, this prediction. Okay, now in part C, we're making a prediction for 1.8 kilograms. Yes, this is also an interpolation, so we'll tick for interpolation. It's within the data points, or within the data that was collected. So the R squared value is the same as before, same data, and plenty of data points as well, same thing. So this last one's the only one that is unreliable here, because although it's got high R squared value and plenty of data, we can see that it is an interpolation. I had to extend the line of best fit, and we only collected data, or data was only collected up to a bird that had 18 grams of hormone, and we're predicting for 22, right? So that's outside the data, so it's an extrapolation. So this one is unreliable. Okay, now what statement could we write? Let me write a quick statement here about this. So this is what we could write. Whoops, just lost it for a moment, bear with me. Okay, my statement is that the predictions from A and C are reliable. Now we want to talk about the points in our statement. We want to touch on all those points, okay? They're reliable because they are interpolations. The R squared value is high. And there is plenty of data. Okay, now part E is unreliable. Now I'm going to make a statement about the fact that it's an extrapolation. And I'm even going to go just a little bit further. It's an extrapolation, so it assumes the relationship holds true for untested values. Okay, and those statements cover that quite well. Righto, so go ahead and look at the description for the video. Start making predictions, but not just making predictions, actually considering the reliability of those predictions.